Hi, my name is Ella, and in the future I'm planning to be an aerospace engineer, which made me especially interested in the Artemis 3 mission, in which NASA is planning to send 4 astronauts to the moon for possibly habitation in the future. However, there's still much to be done, with the deadline soon approaching in 2026, including choosing a final landing spot. So how my presentation is going to be organized is I'm going to go through the background and explain some crucial definitions to the Artemis mission, explain how the project first originated and how it's progressing. Then I'm going to be talking about past research and the gap that led me to what I'm going to be going over, the methodology, which includes a cost-benefit analysis and 6 variables that I explored, the data I collected and its analysis. And these two I'm going to be continuously going in between so it's less confusing. And finally, I will go on to the conclusion and limitations. So first, the background. So the history of the Artemis project began in 1989 and it's still going on today. And it was first started by President George W. Bush, who challenged NASA to expand the space industry through it. The purpose of the Artemis mission was to send man back to the moon to gather more data about it and eventually build long-lasting habitats that would allow humans to sustain life on a place other than Earth. And then the project was furthered when scientists said that they could use the habitations built on the moon to go into Mars on the future. And this project was not formally accepted until 2005 with the NASA Authorization Act of 2005, which officially allowed NASA administrators to establish a program to sustain human presence on the moon. So some people might argue that the US has no reason to spend such money on such a huge program, but there are several reasons why it's beneficial, including public excitement, in which people are going to be donating to the spatial mission, so it's not as costly on the government itself. Furthermore, science development. In the past, the lunar missions have created new technology on Earth. Job opportunities through NASA exploration. A lot of commercial companies have come out to help with the Artemis mission, which leads to a stronger economy. And whenever people are focused on a big goal like the Artemis mission by country, it brings people together. Okay. So this is the part of the overall mission I hope to focus on. It's the Artemis 3 manned mission, and there's 3 goals of this mission: to bring humans to the moon, explore the lunar surface, and achieve scientific goals. These are the 4 astronauts going up to the moon. It's our first black astronaut and our first woman astronaut approaching the lunar surface: Reed Wiseman, Victor Glover, Christian Koch, and Jeremy Hampson. Okay. So there's 3 sub-goals that are especially important, but it's been continuously pushed back. We were supposed to go to the moon by the end of 2024 this year, but the deadline has moved back to 2026 because progress isn't being made fast enough. And according to MIT researchers, the 3 sub-goals that are necessary to complete this goal are carefully analyzing crew safety, as safety is one of NASA's utmost importance, launching cargo to the moon, and creating a capable spacecraft. However, they realized that this needs to be approached while keeping costs to a minimum. For example, this can be super difficult, as 1 kilogram of weight can approach to be anywhere at an extra $550K to $1.2 million more. And this all leads back to the most important principles of going to outer space: choosing a site that's most suitable for the goals of the mission. Next, I'm going to be talking about past research that has been done on lunar landing sites. And that's what my study aims to analyze. If a certain location on the moon is more suitable for the Artemis 3 mission than others. So according to NASA's Lunar Exploration Science Working Group, there are several aspects of a landing site that makes it super important: traversability, safety, geological interest, and other important factors. So in terms of traversability, astronauts need to be able to traverse a decent amount of ground, around a few hundred meters from the landing location, and it's noted that the safest places to land are often not geologically interesting, which is kind of a conundrum for the team. Second, safety is considered to be utmost importance. Obviously, they want to keep the astronauts safe. And then with geological interest, outcrops that are from steep inclined like boulders and surrounding lunar craters are often more geologically interesting than flat land, for example. And this is most likely to have the most variant samples over a shorter distance. The other miscellaneous goals, according to NASA in 2020, is they want a location that has access to significant sunlight, has good communication, like a direct line of communication, and resources, in situ resources such as water and ice. And these various amounts of criteria allow the Artemis 3 mission planning team to focus their lunar location only on the lunar South Pole. They did this because the pole contains ice water and it's in a permanently shadowed regions, which contains a lot of in situ resources. And to explain what an in situ resource is, it's on-site resources, which allows researchers to bring less resources from Earth and utilize the ones that are already on the lunar surface. And something interesting about the lunar South Pole is within 20 degrees of it, latitude, there is a bunch of water, which is one of the main objectives of the scientific goals. Okay. Another reason why the lunar South Pole was a good choice is that it is highly illuminated. It has large access to high illumination areas that get a lot of sunlight, and this is great for solar powered mechanisms, which are going to be the main use of transporting and electricity on the moon. And one of the last reasons why the South Pole is a good place for a lunar landing site is due to both the permanently shadowed regions, ice water, and the high illumination. They should have access to large scale resources. Okay, so in the South Pole, unfortunately, NASA has only chosen 13 landing sites, but they have not narrowed it down despite the upcoming deadline. The problem with this is it's stopping the ability to test if the area is suitable for certain landing and descent mechanisms for the rocket ship, such as based on the area's stability, rockiness, and slope. As a result, my study is going to analyze one of these landing sites in order to determine how suitable it would be for the Artemis mission. I was not able to analyze all 13 due to time restraints and resource restraints. So I chose to analyze the peak at Shackleton Crater. And the reason why I think this is the most suitable from basic research is that it's known to have good in situ resources. It's made of a primitive crust, which holds more history than, for example, newer crust on the moon. The moon's history with it being the oldest basin, and then it has a slope, which, as mentioned earlier, is more geologically interesting. Despite there being studies analyzing the lunar South Pole and its geography and the goals of the Artemis mission, there have been no studies that have looked at the peak at Shackleton Crater in terms of just the Artemis 3 manned mission alone, and this leads me to my research question. To what extent does the possible landing site, the peak at Shackleton Crater at the lunar South Pole, benefit the goals of the Artemis mission in comparison to the distance to nearby minerals, elevation, sunlight exposure, scientific goals, weight capacity, and water exposure that could make this crater a suitable landing site for the Artemis 3 manned mission? So this leads me to my methodology, which is a cost-benefit analysis. And a cost-benefit analysis looks to compare the cost of a mission in comparison to how beneficial that mission would be. For example, having less sunlight would be not as beneficial and more costly, meaning you wouldn't want to choose a landing site that lacks in sunlight. Yes, it is always NASA's goal to get the best out of the mission without spending as much. So in order to get a more understanding of the Artemis mission budget, NASA requested a $6.8 billion budget, but unfortunately they weren't able to directly say where this budget was being allocated. Like, the different variables were unknown, which makes it harder for me to actually connect the dots. And there are 6 variables that I will be analyzing, and that includes the location of the landing site in regards to its distance to nearby minerals, the luminosity or the sunlight exposure, communication, the ability to communicate with Earth, gradient slope, height and steepness of lunar basins, scientific goals, the ability to move around the area, and water frequency, the amount of ice to water nearby. So in regards to distances to nearby resources, according to the ESA, or the European Space Agency, resources such as iron, titanium, and uranium could help refuel a spacecraft in the lunar vicinity and would require less extra fuel to be sent from Earth. Furthermore, according to NASA, resources such as water, oxygen, hydrogen, nitrogen, silicon, and carbon could be used as in situ resources that could be used for the production of fuels, photonic cells, or construction materials, and this makes it so much more beneficial. In order to collect this data, I was planning to use available satellite imagery and compare maps of where that location of resources is and showcase the distance between each of those resources from the base point. Furthermore, the topography of the site is also super important, which includes the gradient or the slope of the surrounding area and the type of terrain, such as it being smooth or rocky. A larger slope means the safety of the mission might be at risk, but at the same time, it could prove to be more geologically interesting. In order to gather this data, I used the rise over run formula and looked at how much of the elevation changes over a certain distance of time. Third, sunlight exposure. With more sun, there's less reliance on batteries, longer work periods, where researchers can work for longer hours without it being too dark when it gets super duper cold. And if the researchers need to go to a permanently shadowed region where it's completely dark, the baseline camp sunlight would allow them to go to those distances for longer periods of time. In order to gather this data, I also utilized satellite video imagery of the peak at Shackleton Crater over a certain period of time, and over that period of time, I calculated how long there was sunlight there and used the percent formula. Okay, and then I also looked at scientific goals. However, there are so many scientific goals that want to be used in terms of the Artemis mission, and due to time restraints, I only chose to look at one, which includes the lunar polar volatiles. And a polar volatile is when chemical elements or compounds vaporize when exposed to air, and these are usually found in permanently shadowed regions. So I'm going to be looking at how far the Shackleton Crater is from the permanent region again, and also the geology, but that relates back to the how far it is from nearby resources. and the planetary processes could occur anywhere on the moon, so I also chose not to incorporate this into my study. Last but not least, water exposure is extremely important into getting the most out of the Artemis mission. In order to estimate how much water is on the moon itself, I will use depictions of data gathered from lasers and satellites with NIR, or near-infrared reflectance spectroscopy, which allows lunar researchers to make distinctions between H2O and other chemical compounds. Following this initial data, like I did with the sunlight, I will be calculating the percent of nearby area that has water. Okay, done.
Oh wait, still questions or you have a question?
That was just-
Oh.